Now we'll be solving question number 30 from previous year problems from chapter Forces, Laws of Motion, and it's a phase 1 book. This question came in 2009. This question came in IIT exam. So let's see. A piece of wire is bent in the shape of parabola. Y-axis vertical, so the y-axis is vertical. This is the parabola. Generally, the mathematics the student study this parabola, meaning when the x-axis parabola is open along the x-axis. Now, when the parabola is open along the y-axis, I can take the equation as y is equals to x square. That was where k is some constant. Now, with a bead of mass m on it, so there is a bead here of mass, and this bead can slide over to it onto the wire without the friction. There is no friction. It stays at the lowest point of the parabola when the wire is pressed. Obviously, because energy will be acting downward in this case. The wire is now accelerated parallel to the x-axis. Now I'm going to accelerate the wire. This whole wire is accelerating along the x-axis with a constant acceleration e. The distance of the new equilibrium position of the bead, where the bead can stay at rest with respect to the wire from the y-axis is. So we have to calculate now. The thing is, the moment I'm accelerating the system, the bead will go in the backward direction because of the pseudo force in this case. So let's say at equilibrium, this is where the bead is. And the distance is x. The distance of the bead is x. Okay. So let me make the tangent on this location. If I make the tangent on this location, at this location, an FBD. So this angle, the angle with the x-axis, I'm taking it as a theta in this case. So when I'm making the tangent, so this is the coordinate system, this is the FBD, and this axis of the FBD, this one, is along the tangent at a general point. So this angle I'm taking as theta. This angle theta, the tan theta value of this angle will be equals to dy by dx. By differentiating this equation, I'll be able to calculate the value of this theta, and by differentiating, this value will come out to be 2 times of kx. That's the value of tan theta. So I know the angle this tangent is making with the x-axis as a function of x. Okay. So this is theta, this is pi minus theta, this angle will be pi minus theta. So this angle will be 90 minus pi minus theta will become theta minus pi by 2. This is theta minus pi. So mg is acting downward. This is the normal reaction. And then there is a pseudo force acting in this direction. Pseudo force value will be equals to m into a. So this is pi minus theta by 2. This total angle is 90. So we'll get this angle will come out to be same as theta minus pi by 2. Now let's take the components. So let's take the component along this line. So if this is the equilibrium position, it cannot slide. If it cannot slide along this line, net force along this line will be 0 and net acceleration will also be 0. So if I take the component of mg in this direction, I'll be getting mg cos theta minus pi by 2, which is same as mg cos pi by 2 minus theta, and that will be equals to mg sin theta. If I take the component of this force along this direction, I'll be getting ma sin theta minus by 2, and that will be equals to ma cos theta. Now for equilibrium, a cos theta will be equals to mg sin theta. Tan theta will come out to be a by g. But we already got the value of tan theta by differentiating the equation of parabola, that is equals to 2ax. And the x from here, you will get it as a by 2 kg. This is k. So that's the location where the system will be in equilibrium. And if you look at the options available, the B option is the correct option. Now, one more time, I'll be recapping this question. It's a pretty nice question. The first thing was, it was not the circle, it was a parabola. If it is a parabola, they went for the equation, parabola equation. Now, with this parabola, we'll be opening along the x-axis. I would have done x is equals to ky square. So once I'm writing the equation of parabola, I know the equation of tangent. So by differentiating this equation, I can calculate the equation of tangent, because dy by dx, in case of any curve, it will give you the equation for tangent. That you learn in case of graphs and all in mathematics you learn. So I've got the equation of tangent, and as you can see, the equation of tangent is depending upon the x. We know the dy by dx, which is the slope ultimately, is nothing but the tan theta, where theta will be the angle with the x-axis. This is one more point. Theta is the angle with plus x-axis. This is the theta. In this case, this is the theta. Then at the equilibrium position, I made the SBD by keeping one of the axes along the tangent. This is the axis along the tangent. Now, if this is the equilibrium, particle is not moving, and the particle can only move along tangent. If the particle is not moving, it can only move along tangent. Then it means the net force along the tangent has to be 0. So out of the three forces, the one force was normal, one force was ma, and one force was mg. The component of normal along the tangent will be 0. But the component of ma and the component of mg along the tangent will be non-zero. So for equilibrium, these two components has to balance each other. We did the balancing and we got the value of tan theta as E by G. And the same value of tan theta we have calculated from the slope equation, and we equated it, and we got the value of x for equilibrium position. It's a pretty nice equation which is involving the deep understanding of mathematics as well as the physics. Okay, thank you.